Welcome to the video lecture series. In this video lecture, we can see about the properties of Z transform. Before going into the properties, a recap of region of convergence. Region of convergence is always bounded by a circle, and its convergence condition is based on the magnitude Z. And as we discussed in the previous video, x of n is equal to a power n u of n, which represents the right-sided sequence, that is infinite sequence, has the ROC always outside the circle of radius A. If it is a left-sided sequence, minus a power n u of minus n minus 1, the ROC lies always inside a circle. For a two-sided sequence, if it exists, then it is an open ring. This is for the finite sequence. For a finite sequence, for n greater than 0, then z is equal to 0 is not in the ROC. That is right-sided sequence. If it is a left-sided sequence n less than 0, z is equal to infinity. It's not in the ROC. ROC is one contiguous region and it does not come in species. These were some of the properties of region of convergence to keep it in remembrance. Moving on to the properties of Z transforms, which are used in different types of applications based upon the property. For example, first comes the linearity property, which is mostly used to decompose the given signal into multiple signals and analyze. Here, for example, if two signal sequence x1 of n and x2 of n is considered. During analysis, they may be multiplied with constant a or like constant b, and if it is added, the same linearity will occur in the frequency domain also. The ROC here will be the intersection of the two. So the linearity means that it is preserved in both time and frequency domain. Whereas time shifting, for example, x of n minus k, minus 1, minus 2, minus 3, as I mentioned in u of minus n minus 1, if the signals are shifted and it is represented in time domain. While going for frequency domain, we multiply it by z power minus the shifted levels into x of z. This is the time shifting property which is used in while designing the filters and all. This time shifting property plays a major role in the filter design. ROC is except z is equal to 0 if k is 0 less greater than 0 and z is equal to infinity if k is less than 0. Time reversal property will be used to identify the symmetry of the signal. X of minus n means x of minus z power minus 1. That is x of z inverse. X of n is x of z. X of minus n is x of z inverse. So this is time reversal property. Differentiation property. N this multiplied by x of n. It is on differentiation we get the frequency domain. Convolution property, it's just a multiplication in Z domain. That is one of the added advantage of the Z transform. Other two properties are initial value theorem and final value theorem, which helps to find the initial value of the signal without going on to the inverse Z transform. X of 0 is equal to limit z tends to infinity x of z. Final value theorem is x of infinity when limit z is equal to 1, z minus 1 into x of z. This helps to find the final value and initial value during the signal analysis. Coming on to few problems on Z transform and by using its properties. So we all know that del of n, which is equal to 1 at n is equal to 0 and it is 0 otherwise. For this representation, we can rewrite it as a sequence like this. Del of n is equal to 0 at negative axis, 0 at positive axis. At reference alone, its value is 1. This is the meaning of del of n. So when we write the Z transform, only at reference, that is z power 0, we have z value. All other cases, it is multiplied by 0, so it is eliminated. So 1 into z power 0 is 1. X of z for del of n is 1. For an impulse function is 1. Are you clear in this? Impulse function means at reference 0 alone, an amplitude 1 will occur. All other places it is 0. So we have x of z as 1 for this. Remember that impulse function x of z is 1. Why I say is, now this is the ROC, this has the unit circle. Coming to the problem 1, x of n is equal to del n minus 1. Which property you can use here? We can go for time shifting property, because in the place of n we have n minus 1. So time shifting property will be best suited for this, for solving this problem. So what is time shifting property? We'll get x of z by multiplying by z power. Do you remember? I think time shifting property, it is z power minus k into x of z. In the location of k, now we have 1 for this problem. In the k, it is 1. So z power minus 1 into x of z, which x is the transform of del of n, because the actual function is impulse function. So del of n, for del of n, in the previous only we have found that x of z value for del of n is 1. So on substituting it as 1, we get the x of z final value as z power minus 1 for this particular problem. So just by applying the time shifting property, we can easily uh, s- we can easily solve the problem. Instead of using the direct z transform formula, that is n is equal to minus infinity to infinity x of n z power minus n, and after using all the mathematical concept, we can get it. But by using time shifting property, it is easy to get. For example, if it is minus 2 here, what happens? Here we will get minus 2, z power minus 2. If it is minus 3, it is z power minus 3. I hope you understood. It is the ROC, if you take, it is an entire z plane except z is equal to 0. Coming on to z transform of unit step function. Unit step function, u of n, already while discussing a of n u per n, we saw what is u of n. It has the value 1 for n greater than or equal to 0 and 0 for n less than or 0. So coming on to the unit step function, minus infinity to infinity, u of n z power minus n. So since it has values only from 0 to infinity, we modify the limits from 0 to infinity. Its value is 1 always, because it is a unit step function. 1 into z power minus n. So this geometric formula, we know a power n 0 to infinity is 1 by 1 minus a. Instead of a, we have z inverse. So on solve, this is applicable only when a is lesser than 1, because this we have to be careful. When a is greater than 1, the value will become surely infinite at once. When a is greater than 1, a value will go on increasing like this. It goes on increasing up to infinite. Surely we'll get some infinite value. So this geometric formula is applicable only when a is less than 1. Here the a is nothing but z inverse. Z inverse is less than 1 or z greater than. Z inverse is less than 1 or z greater than, or we can say it is z greater than 1. Now I think you got ROC. ROC should be finite value. We should. So geometric formula applies only when a is less than 1. Keep this in mind, which I have not mentioned in the previous video. These were the references taken. Thank you. Stay tuned.